All right, today we are going to be talking about the focus of a parabola. And let me show you where the focus is located. You're going to have a parabola, which the cursor is drawing it right there. That focus is kind of, it's not really the center of the parabola, but it's on the line of symmetry. And that line right there, that y equals -2, is called the directrix, and that is going to be the same distance from there to there. So what we're going to do is we're going to use a distance formula to write the equation of the parabola with a focus of 0, 2, and a directrix of -2. So we're going to notice the line segments drawn from point F to point P and point P to D. And by definition, they must be congruent or equal. That is going to be your definition of a parabola. From focus to a point to that directrix, they're equal. We're going to use that distance formula. You might have to think back to geometry. Distance formula is the difference of x's squared plus the difference of y squareds, square root. We're going to plug in what we know. We have an ordered pair of 0, 2, and an ordered pair of x, -2. So x, -2 went in there, 0, 2 went in right there. Doesn't really matter which one you put in first. Now you're just going to solve. Simplify, and you get y plus 2 quantity squared, x squared plus y minus 2 quantity squared. That's all underneath the square root. Take square both sides, the square roots cancel. FOIL that out. Remember, that's y plus 2 times y plus 2, y minus 2 times y minus 2. And now you get to just simplify it out. Y equals 1/8 x squared. Oops, I just showed you the answer. This was supposed to be kind of a you try it. I know the answer was just up there, but take a second, pause your computer, try this answer, and then check yourself. All right, I'm going to give you a few formulas here. If I were taking notes, I would probably pause and write some of this down. This is going to be important information. So we've got parabolas here where your axis of symmetry is x equals 0. Okay, your vertex is 0, 0. So your directrix is going to be y equals -p, where p would be a constant. Your focus is 0p. In the equation, it's going to be 1 over 4p x squared. That's if it's going up or down. Every once in a while, we're going to deal with parabolas that open right or left. Instead of y equals, those are just x equals. And it's the same kind of situation. Your focus now, though, instead of 0p, is p0. And your directrix, because it is a vertical line, is going to be x equals -p. And the equation is x equals 1 over 4p y squared. So let's go ahead and identify the focus, directrix, and axis of symmetry for -4x equals y squared. Oops. Sorry about that. It's wrong button. So we're going to first rewrite this in standard form. Divide by -4, and you get x equals -1/4 y squared. So now we need to identify the focus, directrix, and axis of symmetry. Well, it's x equals 1 over 4p y squared. So in this case, p is going to be -1. You would just take -1/4 and set that equal to 1 over 4 P. Not the best handwriting there, sorry. And you solve for P and you get -1. So the focus is going to be -1, 0. The directrix, it's going to be x equals -1, which would be +1. And then we could go ahead and graph that. Your directrix, x equals 1. Your focus, y equals negative. I'm sorry, your directrix is x equals 1. Your focus is -1, 0. Make a t-table there. I probably would have just chosen 2 points and done the mirror image of them because you know the axis of symmetry. All right, here's one where it's opening downward, so they're giving you the vertex, it's 0, 0, and they're showing you the directrix. We need to come up with an equation. Well, because vertex is at the origin, and it's opening downward, we know it's going to be y equals 1 over 4p x squared, and the directrix is y equals -p, and the distance there from the vertex to the directrix is 3. So p is going to be -3. That's really the hard part of it right there. So you plug that in, you know what p is, and you're going to get -1/12 x squared. Because of that distance right there, which was 3. All right, these are kind of a you try. So identify the focus, directrix, axis of symmetry, and then graph. I would pause, and then you can check your answers in a few minutes. All right, what about when the focus, or I'm sorry, when the vertex is not at the origin? It's going to be at HK, which is probably going to be more of a common occurrence. This looks pretty complicated, but it's really not that bad. It's really the same formula. You just have H and K in for your translations for right or left, up and down. Your focus is going to be H, comma, K plus P, and your directrix is going to be Y equals K minus P. What I would really suggest is you write these down really neatly, and as you're doing your homework, have this as kind of a little bit of a cheat sheet out in front of you and use it as a reference. You're going to find it very helpful. For the horizontal axis of symmetry, where it opens either right or left, H plus P is your focus, H plus P, comma K. Directrix is going to be X equals H minus P. Again, I would probably have to pause and write this down. So here's one where the vertex is definitely not at the origin. They give you the focus, and you are going to have to come up with an equation. So first of all, figure out what formula you're going to be using. It opens right, so it's going to be an x equals. So x equals 1 over 4p, y minus k, quantity squared, plus h. Well, h and k, I think, are pretty easy to come up with. The vertex is 6, 2. Make sure you notice that they're counting by 2's on your hash marks. And your focus is 10, 2. Well, we also know that the focus is H plus P, comma K. So we can figure out what P is. We know what H is. H is 6. H plus P is 10. Therefore, that P has to be 4. Once you've done that, you've done all the hard information. Plug everything that you know in, write your equation. that is it. I hope you enjoyed the focus of a parabola.